Hey everyone, and welcome back. Today we're doing a deep dive on something you might know more by smell than by its scientific name. Ozone.
Yeah.
You know that crisp, clean scent in the air after a thunderstorm?
Right.
That's ozone. But there's way more to this molecule than just a pleasant aroma.
Definitely.
We'll be looking at excerpts from a chemistry textbook
Yeah.
to uncover the secrets of ozone. Don't worry.
Right.
We'll give you the key insights without getting bogged down in all the technical jargon.
Exactly.
So what are the big questions we're going to answer today? What is ozone exactly, and where is it found? Why should we care about it? What's the connection to human health and the environment? And how is ozone formed and destroyed, and what role do we play in all of this?
Sounds like a plan.
All right, so let's start with the basics. What exactly is ozone?
Well, in simple terms, ozone is a special form of oxygen. Instead of the usual two oxygen atoms we breathe, O2.
Well,
Ozone has three, making it O3. And it's what we call an allotrope of oxygen.
okay, an allotrope? That sounds like one of those terms I haven't heard since high school chemistry class. Can you break that down for me and for our listeners who might be in the same boat?
Absolutely. An allotrope means it's made of the same element, in this case, oxygen, but the atoms are arranged differently. This difference in arrangement leads to different properties. Think of diamonds and graphite.
Oh, yeah.
Both are pure carbon, but one's incredibly hard and the other is soft enough to use in pencils. That's because their carbon atoms are bonded in different structures.
Ah, I see. So even though ozone and the oxygen we breathe are both made of oxygen atoms, they act very differently because of how those atoms are linked up.
That's fascinating. So where do we find this ozone? Is it floating around everywhere?
Well, ozone exists in two main layers of our atmosphere, the stratosphere, which is way up high,
Okay.
and the troposphere, which is closer to the surface where we live. And interestingly enough, its impact on us changes depending on where we find it.
That's a bit of a twist. It's like ozone has a split personality.
Uh-huh.
Good ozone, bad ozone.
You could say, let's start with the good stuff. Tell me about ozone in the stratosphere.
That's where we find the famous ozone layer, a region about 10 to 50 kilometers above the Earth's surface. It acts like a giant invisible shield, absorbing most of the sun's harmful ultraviolet or UV radiation.
So it's protecting us from those nasty sunburns and worse, right? What happens if that shield weakens?
That's where it gets really interesting.
You're right.
And concerning.
Uh-oh.
In 1958, scientists made a startling discovery, a significant depletion of ozone over Antarctica.
Really?
Literally a hole in our protective shield.
Wow.
This meant more harmful UV radiation was reaching the Earth's surface, putting us all at greater risk for skin cancer, eye damage, and even harm to plants and animals.
Let's see. So a strong ozone layer. Good. A weakening ozone layer? Not so good. I'm starting to understand why we should care about this invisible molecule. But how does ozone even form in the first place, and what causes it to break down?
Well, it's a fascinating natural cycle, a delicate dance between creation and destruction.
Yeah.
Up in the stratosphere, UV radiation from the sun strikes oxygen molecules, O2, and splits them apart, freeing up single oxygen atoms. These lone atoms then collide with other oxygen molecules, forming ozone O3.
So sunlight is actually involved in creating the very thing that protects us from its harmful rays. That's a pretty neat trick.
It is. But the process doesn't stop there. UV radiation also breaks down ozone, releasing oxygen atoms to start the process all over again. It's a continuous loop, a natural balance that keeps the ozone layer at a relatively stable level.
That's a pretty intricate cycle. What happens if something throws it off balance?
Well, that's where human activity comes in. We started using certain chemicals, specifically chlorofluorocarbons or CFCs, that messed with this natural balance.
CFCs, those ring a bell. Were they in things like refrigerators and aerosol cans?
Yeah.
Seemingly harmless stuff.
Exactly. CFCs were considered wonder chemicals, non-toxic, non-flammable, and incredibly stable. But what we didn't realize is that their stability would become a problem up in the atmosphere.
So these CFCs, seemingly innocent down here on Earth, travel up into the atmosphere. What happens next?
Because CFCs are so stable, they can float all the way up to the stratosphere without breaking down. But once they reach that altitude, the intense UV radiation breaks them apart, releasing chlorine atoms.
And those chlorine atoms cause trouble.
Yay!
What's their role in all of this?
Those chlorine atoms are the culprits in the ozone depletion story. You see, chlorine acts as a catalyst.
A catalyst. Remind me what that means again.
A catalyst is a substance that speeds up a chemical reaction without being consumed itself. In this case, a single chlorine atom can initiate a chain reaction that breaks down thousands of ozone molecules. It's like a tiny wrecking ball, smashing ozone molecules over and over again. This chain reaction tipped the scales, causing more ozone depletion than natural processes could replenish, leading to the ozone hole.
So one tiny atom can trigger the destruction of thousands of ozone molecules. That's incredible. What happened when scientists discovered this link between CFCs and ozone depletion? Do we just continue using these chemicals?
Fortunately, no. The discovery of the ozone hole sparked a global response. Scientists sounded the alarm, and international agreements like the Montreal Protocol were established to phase out the production and use of CFCs.
That's encouraging. So is the ozone layer all healed now?
It's a slow process,
Okay.
but there's good news.
Oh, good.
The ozone layer is showing signs of recovery,
That's great to hear.
though it's expected to take several decades to fully return to pre-1980 levels.
Wow, that's a long time.
Oh, it is.
So we're not out of the woods yet.
Not completely.
I thought we had solved the problem by getting rid of CFCs. What else can damage the ozone layer?
There are other natural and human-made factors at play.
Like what?
Volcanic eruptions,
Oh,
for instance, can release ozone-depleting gases into the stratosphere.
I see.
We also have to consider the excessive use of nitrogenous fertilizers in agriculture,
Really?
which release nitrous oxide, another ozone-depleting substance.
It seems like everything is connected. Even our farming practices can impact this invisible shield way up in the atmosphere.
Precisely. And we can't forget about the exhaust from supersonic jets,
Oh, yeah.
which also contribute to ozone depletion.
So the story of ozone is more complex than I initially realized. It's a reminder that seemingly small actions, the products we use, the way we farm, can have big consequences on a global scale.
Mm,
But let's not get too doom and gloom.
right.
We've talked about the bad side of ozone,
Yeah,
but what about the good? I know it has some beneficial uses, right?
you're absolutely right.
Right.
Ozone has a dual nature, and its uses can be both beneficial and harmful depending on the context.
Okay, let's dive into the good stuff.
Sure.
What are some ways ozone is actually helpful?
One of the most important uses of ozone is in water purification.
Okay.
Ozone is a powerful disinfectant,
Oh, yeah, I've heard
much
about.
stronger than chlorine,
Wow.
and it's often used in swimming pools and drinking water treatment plants to kill bacteria and viruses.
So ozone can help keep our water safe to drink. That's pretty essential.
It is. And that fresh, clean smell you notice around swimming pools,
Yeah.
that's often from the ozone used to keep the water clean.
So that fresh air smell we talked about earlier, the one after a thunderstorm, could actually be ozone cleaning the air. That's amazing.
It's possible.
Huh.
Ozone is also used for air purification in enclosed spaces like tunnels, theaters, and even food storage facilities
Interesting.
to remove odors and pollutants.
It sounds like ozone is quite the multitasker. Any other surprising uses?
Ozone is also used for bleaching fabrics and preserving food in cold storage.
Really?
It can even be used in medical treatments to disinfect wounds and promote healing.
Wow. Ozone is a jack of all trades,
Mhm.
from purifying water to bleaching fabrics.
It is a versatile molecule.
But as we've learned, it's important to use it wisely. Before we wrap up our deep dive, I'm curious about one thing.
Yeah,
We've talked about how ozone forms naturally in the stratosphere,
right.
but can we also create it artificially?
We can.
Yeah.
One common method is to pass pure dry oxygen through a high-voltage electric discharge, similar to what happens during a lightning storm.
So we can mimic nature in the lab to create ozone. That's pretty cool. Why would we want to do that?
This process is often used to produce ozone for those industrial applications we discussed, like water purification and air treatment. But creating ozone artificially also allows scientists to study its properties and better understand its role in the atmosphere.
That makes sense.
Yeah.
By studying ozone in a controlled setting, we can unlock its secrets and learn how to protect this vital molecule.
Yeah.
So we've covered the formation of ozone, the threats it faces, and even some of its surprising uses. But I'd like to circle back to the ozone layer for a moment.
Okay.
We touched on the consequences of its depletion, but I'm curious about the specific effects.
Yeah.
What happens when that protective shield weakens?
The consequences can be far-reaching
Okay.
and impact all forms of life on Earth. Let's start with the most direct and well-known effect, increased exposure to harmful UV radiation.
Okay.
This can lead to a rise in skin cancer cases,
Right.
including melanoma, which
Right.
is the most dangerous type.
I knew about the skin cancer risk, but what other health problems can UV radiation cause?
It's not just our skin that is vulnerable. Our eyes are also at risk. Increased UV exposure can lead to cataracts,
Oh, wow.
which cloud the lens of the eye,
I see.
and photokeratitis.
What?
Photokeratitis. It's a
Right.
painful condition that's like a sunburn on the cornea.
I had no idea. So ozone depletion isn't just a problem for sunbathers. It can affect our vision too. Are there other impacts beyond human health?
Absolutely. UV radiation can damage plants, interfering with photosynthesis and reducing crop yields. It can also harm marine ecosystems,
Wow.
particularly phytoplankton.
Phytoplankton.
Yeah, they're tiny organisms that form the base of the food chain in the oceans.
So a weakened ozone layer can disrupt entire ecosystems from the microscopic level all the way up to humans.
Exactly. And there are also concerns about the impact of UV radiation on animal life,
Oh no.
leading to mutations and reduced populations of certain species.
It's a sobering reminder of how interconnected everything is on our planet. We've talked about the role of CFCs in ozone depletion,
Right.
but you mentioned other human activities that contribute to the problem. Are there other sources of ozone-depleting substances besides those volcanic eruptions?
There are, besides the combustion of fossil fuels,
Okay.
which releases various pollutants, including nitrogen oxides,
Uh-huh.
we have to consider agricultural practices, specifically the excessive use of nitrogenous fertilizers.
How do fertilizers damage the ozone layer? They seem pretty harmless on the surface.
These fertilizers release nitrous oxide into the atmosphere,
Oh, yeah.
which is a potent greenhouse gas,
Right.
and also contributes to ozone depletion. And let's not forget about deforestation.
Hey, trees help protect the ozone layer? I'm not sure I follow that connection.
Indirectly, yes, trees play a crucial role in absorbing carbon dioxide from the atmosphere,
Okay.
helping to mitigate climate change, which in turn has implications for the ozone layer.
It all comes back to that interconnectedness you mentioned. It seems like we're facing a complex web of environmental challenges that are all linked.
You've hit the nail on the head. It's not just about tackling one issue in isolation. We need a holistic approach that addresses climate change, pollution, and ozone layer depletion simultaneously.
That sounds like a tall order. But I have to believe that solutions exist. What steps can we take to protect the ozone layer and reverse the damage that's been done?
You're right. It's a challenge, but not an insurmountable one.
Okay, good.
We've already seen the positive impact of international cooperation with the Montreal Protocol. We need to continue phasing out the production and use of ozone-depleting substances.
And what about those other factors we discussed, like nitrogenous fertilizers and deforestation?
We need to promote sustainable agricultural practices
Right.
that reduce reliance on these fertilizers. This includes things like crop rotation, organic farming methods, and precision agriculture techniques that optimize fertilizer use. And for deforestation, protecting existing forests and promoting reforestation efforts are crucial. We need to recognize the vital role that trees play in maintaining a healthy planet. Planting a tree might seem like a small act, but when millions of people do it, the impact can be significant.
Those are all great steps. But what can individuals do?
Yeah.
It can feel overwhelming to think about tackling such massive global issues. What can our listeners do in their everyday lives to make a difference?
You're right, but every individual action counts.
Really?
We can all make conscious choices in our daily lives that contribute to a healthier planet. This includes reducing our reliance on fossil fuels by opting for public transport, cycling, or walking whenever possible. We can also conserve energy at home by using energy-efficient appliances and simply turning off lights when we leave a room.
Yeah.
And supporting businesses and organizations that are committed to sustainability is a powerful way to vote with our wallets.
Those are all things we can do right now. It's empowering to know that we're not powerless in the face of these challenges.
Exactly. We all have a role to play in protecting our planet. And remember, knowledge is power. The more we understand about the science of ozone and the complex interplay of environmental factors, the more equipped we are to make informed choices and advocate for positive change.
Well said. We've covered a lot of ground in this deep dive, but I feel like there's still so much more to explore. Are we ready to wrap things up, or is there anything else you'd like to share with our listeners?
We've certainly delved into the key aspects of ozone science and its impact on our world. But before we conclude our deep dive, I'd like to leave our listeners with one final thought.
I'm intrigued. What is it?
Well, as we've discovered during this deep dive, ozone is a bit of a paradox, isn't it? It can be both our protector and a pollutant, a vital shield high in the atmosphere and a harmful irritant closer to Earth's surface.
It really highlights how complex our relationship with nature can be,
It does.
and how important it is to understand the science behind things before making decisions that could impact the delicate balance of our planet.
Absolutely. The story of ozone depletion and the global effort to reverse the damage shows just how powerful human ingenuity and cooperation can be. But it also reminds us that we need to remain vigilant and committed to those sustainable practices we talked about. We can't afford to let up.
So what's the takeaway for our listeners? What can they do with all this new knowledge about ozone?
Learning about ozone is a great first step, but it's just that, a first step. The real power comes from using this knowledge to make informed choices in our daily lives and to advocate for a healthier planet.
You mean like supporting policies that promote ozone layer protection? Being mindful of our own consumption habits and encouraging others to do the same?
Exactly. Remember, even small actions can have a ripple effect.
And those conversations we mentioned, talking to friends and family about these issues, that's a powerful tool for raising awareness, right?
It is. Every voice counts when it comes to creating a more sustainable future.
This deep dive into the world of ozone has been fascinating and eye-opening. I feel like I've gained a whole new appreciation for this invisible but essential molecule. Any final words of wisdom before we sign off?
Remember that the story of ozone isn't over. The choices we make today will determine the fate of this vital layer and the health of our planet for generations to come. So let's choose wisely.
Well said. Thanks for being our guide on this incredible journey into the world of ozone. And to all our listeners, thank you for joining us on this deep dive. We'll see you next time for another fascinating exploration into the world around us.